The liquid crystal cell model, or LCC, allows detailed studies of liquid crystal device behavior. It can describe a broad range of commercially important devices. A critical feature of the LC model is how the orientation variation is described. This command has several ways of inputting orientation data. The orientation parameters, tilt and twist, can be specified first by a simple linear variation of one of them. In this case, phi is what is often called twist, and it varies from 0 to 90 degrees in 20 steps. This is useful for very simple models. For a slightly more complex model, we might want to vary tilt and twist at the same time. In that case, we use, in the LCC command, the both keyword, and in this case, the table keyword tells everything we need to know about both tilt and twist as we go through the thickness of the device. So we have 20 layers in thickness. The total thickness is 5.9 microns, and it is indicated here by the coordinates in the first column. So let's just take a look at the first model. This is a model for a normally white twisted pneumatic crystal in its on state. So just to orient you a little bit, the center is straight ahead. As we go off to one side or the other horizontally, these are horizontal angular directions, and the vertical is vertical angular directions. And we're basically showing a whole hemisphere in this case. Now let's take a look at how this compares to the table form. In this case, we're varying both parameters, not just the twist. Notice that for the table, the tilt is a small value. It's 2 degrees, but that's just enough to make a bit of a difference in the model. So as we run that, we get a result that which you might say looks pretty much like the other one. To be able to compare that, let me actually remove the scripts, and then I can just go back and forth between them. So this is the simple model. This is the more complex model. One thing about the more complex model is that its peak throughput is a little bit higher. The simple model has slightly wider characteristic in terms of going through a wider direction with higher transmission, but it's a very small effect. Of course, if you're doing studies of viewing out near the 90-degree point, it's very important to have a model that describes that fully. One other thing that we may notice here is that between the simple model and the slightly more complex model, the complex model exchanges energy at the edges for energy at the top and bottom. So this distinction can be very important in modeling device performance near the edges of the visual field. Another way of describing orientational information for the liquid crystal device is using equations. So taking a look at this LCC command or liquid crystal cell command, we have the both keyword, but instead of having the table keyword after it, we have LC underscore tilt and LC underscore twist. What these are the names of ASAP dollar functions which describe the tilt and twist. And let's just scroll up a little bit to show you what one of those may look like. We have a dollar function here. This is LC underscore tilt, and we have a function, an actual mathematical function that describes that tilt function as we go through the thickness of material. We then have a function that describes the liquid crystal twist, and it's another function to describe just the twist part of the functionality for the orientation. And we apply this to a cascaded device which has crossed polarizers, with the LCC between them to model the liquid crystal device. The full device, including the switching mechanism of the polarizers. This LCC device is in the off state as opposed to the other two, which were in the on state. So I've plotted the LC tilt and twist functions just so that you get an idea of what the profile looks like. The tilt is a sort of high order even function. The twist is a fairly steep transitioned odd function. So now let's take a look at the transmission for this. Again, the center is straight ahead. We have bright spots in 4 edge positions, and we have a sort of X-shaped dark characteristic, which we would hope to have a dark characteristic for the off state, but we have some bright spots. In fact, up to 30% intensity transmittance in this lower bright spot, which is not desirable and is the reason we want to model more sophisticated devices. But it's a good beginning design and shows that the liquid crystal cell model is working properly.